This lesson will be about diffraction. If you remember what happens when you see waves approaching a gap, they will bend at the edges. If the gap is smaller, they will bend more around the edges like that. So we'll discuss diffraction. Again, we will do practice examples in another video. This will just be talking about the idea and the theory behind things. So we'll understand diffraction, introduce the diffraction grating, and we in the class will be solving some problems together. So diffraction is waves when they go through gaps, they bend around the edges. You can put your fingers together and you can actually notice if you bring them close without touching, you'll see darkness in between before they even touch. That is the light bending. You will see that happening in a screw and other things as well. We're going to focus on what happens when it goes through a slit and onto a wall. Okay. What we'll see is if we're trying to find this out, we will have a formula that you may be familiar with from before. And we have this distance here, this x right here. Same kind of idea. There's a slit, there's a wall, and there's some angles. We'll deal with the angles later on. If this is my x, and this is my L, just like before, and instead of having the distance between two slits, we only have one slit now, so I'll replace D with this width, the W. Our formula will become 2 wavelength L over W. Of course, you can take this 2 to the other side, because remember there's two x's, which is where this comes from. And you can end up cancelling the 2 out, and you have something like this. Okay. So this is the rule that we can use to find the vertical distance, which we've previously used as y. Sometimes it's x. It'll be interchangeable, so you can find out which one's which. You can use it. It doesn't really matter. Okay, so there's a quick example that we did do, and I will do that again in an example tutorial another time. This is a diffraction grating. This is when you have a little box and you have so many different slits in between. Okay, and what happens is the light will pass through and it'll interfere with each other using Huygens principle from the previous lesson. You'll get lots of spots, bright spots and dark spots. You did a little simulation in the class. You realize that when you make the screen further away or closer, it makes a difference to the dots, and you find out if you add more lines or remove some lines, it makes a difference. I will not give away what happens in this. You will try it yourself during the simulation. But essentially, you will know that a grating has lots of these things, lots of angles, lots of diffraction. It helps you get a clearer diffraction pattern on the screen further away. Okay, so more light, more interference, more clearer. It's happening more often, so you can see more lines. This is useful, so we can investigate atomic spectra. We can see the light emitted from electrons passing through a tube, and you can see that certain gases will show different colors, different bands. We can combine them and figure out all the different elements inside a gas. We can even use them to help us determine what elements are inside the sun, for example, by passing the light from the sun through one of these gratings. And you can see that on an absorption spectrum, you will see certain lights passing through. Really useful stuff. So this is how it would look. There's a laser, shine it, and you will see the different interferences, the bright spots. Dark spots will be in between. There'll be nothing going on, but you will see principal order maximum. So 1, 2, 3, minus 1, minus 2, minus 3, like this. We can use the same formula as before. We can use d sine theta equals m lambda. That will help us calculate the wavelength. It can help us calculate anything we need, really. Okay, so that's a rule that we can use for the diffraction grating. However, there is one extra thing. This D, this is the difference between the slits, and because you have so many slits, you will have to figure it out by figuring out how many numbers are in the slit. So you'll take one box and you'll divide that by the number of slits. That will tell you D, the number of slits or number of lines. Okay, so this is important to find D first if you don't actually have the distance between them. Okay, so you might get a question saying you get 500 lines per millimeter and you have to figure out how much distance is between the slits. So we know it's 500 lines per millimeter. How many is that per meter? Well, we know there's 1,000 millimeters in a meter, so we can just multiply that by 1,000. So you have this many lines per meter. You can do 1 over D to get your answer. Okay, and that will give you your D. And you can use that to calculate a question. You can solve problems using that, and we will be doing this in class. Very straightforward. Nothing too difficult there. Some more practice questions that you can do, and sometimes you might need to find the angle, rearrange the formula to find the angle to get the sine -1, sine inverse. And there's something called lenses and Rayleigh criterion. Lenses is the stuff that you'd have like in your glasses and things like that, circular lenses and cameras and so on. If you have a lens, because it's circular, we will need to find the diameter of that from one side all the way to the other. If the center of the bright spot of one of the image is in the dark ring of the second image, they will reach the limit of resolution. So you have two images and you will see the bright spot of one, the dark spot of the other. You will see something that looks like this. This is when light's passing through whatever my object is. It will pass through the telescope. You will see the image on a screen, and you can calculate the size of this object by doing this rule: 1.22 multiplied by lambda and the distance, the L, this distance here, divided by d, okay, which is the diameter. That will help us find the lenses and the objects and so forth. Very useful stuff, okay. That's all we need to know for this part of the lesson. I will do some practice stuff in the next video.